Hi, welcome to the video where we're going to be making observations about our box plots. In the previous class, we learned how to actually make them using the 5 data points, the lower extreme, the lower quartile, the median, the upper quartile, and the upper extreme. And getting started today on this page, we're going to be exploring something called the interquartile range, or the IQR. Now, that was a question that you guys had on your previous page that you had to submit in the last class in a Google form. The question right here, number 12, it asks what's the IQR of the scores, and there was a hint in the Google form that mentioned that the IQR is the interquartile range, which is the range between our two quartiles. So you have your upper quartile and your lower quartile, and so the interquartile range is simply the answer when you subtract those two. So if our upper quartile was 92 and the lower quartile was 63, if we subtract, the IQR is a 29 here. Now, one of the things we had to do in the last class here was compare what happens when it looks like you kind of zoom in on the scale. I want you to kind of imagine we took this box and whisker plot and we kind of pinched the screen to kind of zoom in, and that's what happens when the scale has adjusted here. It's been kind of zoomed in a little bit. And when we zoom in on the scale, it almost looks like this data is more spread out. The 29 that's represented from here is still the same 29 represented here. So we are actually in control with our scale. If we want to manipulate the data to appear to be a little bit more spread out, we can certainly adjust our scale. Also, on the flip side, if we want our data to appear more closely clustered together, we can adjust the scale for that as well. So I just wanted to kind of briefly touch base from the last class on what this was meant to look like, and then again the IQR. And now here we are ready to get going. When we want to consider the IQR, it's because that right there represents two of our quartiles, or 50% of the data. And a lot of times when we're looking at certain data sets, where 50% of it lies is a pretty good indicator of the data set. So that's why the IQR, or the interquartile range, is something that we care about. Now, what we look at here is it looks like there's a teacher, Miss Neal, and Miss Neal has 5 different classes, and these are the box plot to represent the scores. It looks like in her first period class, there's 30 students. In second period, there's 22 students, and so on. So each class does vary in size. When I look at the data, one thing that kind of stands out to me is that, for example, the scores in her 5th period class appear to be really spread out. The scores in her first period class seem to be really kind of closely clustered together. Now, when we look at the interquartile range, basically we're focusing on the box of the box and whisker plot, okay? Because again, IQR is from here to here, and that represents 50% of the data. So let's look at the interquartile range on the test scores for these different classes, okay? Now, for this first period class, this right here is a 95. And when we take this 95 and we subtract 85, this has an IQR of 10. Okay, 95 minus 85 is 10. Now, the next one, if I extend this one down here, that's an 80. And if I extend this down, that's a 55. So 80 minus 55, 80 minus 55. That's a 25. Be careful with that one. It's a little tempting to say 35, but we've got 10, 25. All right, now for the next one. For third period, if I drop this line here, it's going to drop down to the 85. And if I drop this line down here, it drops to the 60. So I've got the 5, 10, 15, 20, 25. So you can see that 50% of the data here and here has a range that's the same. But it looks like for the third period, because you see how this box, this half of the class is a little higher up, that lets us know that third period might have done a little bit better than second period, because again, this half, and let me kind of highlight it here, that chunk of data is a little bit higher up on the number line than this yellow chunk of data for the other class, okay? So again, we're just kind of looking at this box in the interquartile range. And again, we kind of care about it because we're looking at half the data. And if a teacher is kind of looking at this, the way that the classes did and kind of comparing, looking at about half the class is definitely a good way of kind of looking at the data. Now, when we continue on here, we've got fourth period left. When I extend this line down, that one we kind of have to estimate. You might disagree with me. It's going to be somewhere between 80 and 85. I personally am going to go with 83 for this one. I think that's kind of closer to an 83. Now, when I drop this line down, though, that's right at 50. So 50 to 83, I'm going to come up with an IQR of 33 for that one. And this one, when I drop the line, again, if you drop it, it falls in between the 85 and the 90. You might disagree with me, but if you look in your packet and extend it all the way down, to me, I'm going to go with an 86 for this one. And when I drop this line and extend it all the way down, in your packets, I think you guys would agree that this one is right at the 45. So if I do the 86 minus 45, 86 minus 45, that is an IQR of 41. Now we can see here that this IQR is much smaller than this IQR, which again lets us know that this class, they scored more consistently around each other. Now I want to point out that this consistent chunk could have been way down here. And consistent doesn't always necessarily mean better. It just is pointing out that a lot of the students are closely clustered together, kind of around one score, versus one class being super spread out with the data, okay? So we've got our interquartile ranges for each of the different classes, and I'm going to just erase that right now. And what we're going to do is we're going to go through answer choices A through G, and we're going to select all of these which are true statements. And I'm just kind of teaching you guys how to go through and make observations about the box and whisker plot, which if you look at the title of today's notes, that's what we're doing here. We're just trying to make observations. Now the first statement here, answer choice A, it says the lowest score in first period was a 65. So if I'm looking at first period, there was 30 students. When I look at the box plot, the lower extreme is right here, and that is in fact at the 65. So yes, we're going to select that as a true statement. Now, half of the third period class must retake the test, and it looks like in this school in this class to retake, you must have gotten lower than a 70. So basically, we care to see if half the class in third period is below the 70. Another way of asking this is the median a 70? Now, when I look at third period, I'm right here. This line is the median. So half the class is performing below it and half performed above it. If I drop this line down, it is at the 70. So it does look like half the class scored below that line. And so yes, half the class is going to need to retake. So third period, when we look at that data and consider that half the class needs to do a retake, that's not so good. In fact, if we care about 70 being the cutoff right here, obviously this class did way better than that. Half of this class is going to need to retake, kind of like here. Now this class, half of this class did worse than a 60 and half the class did better than a 60. The interesting thing about that is that the half that did better than this 60, we have no way of knowing what their scores were. So they could have had something like a 62 or a 65 and would need to retake. So with this class, we cannot really conclude anything about the retake situation. We obviously can see here that at least 14 kids, at least these kids who got below a 60, obviously if they're below a 60, they're certainly below a 70. So we know at least 14 of them have to retake, but we can't really make any conclusions about up here how many who got higher than the 60 would need to retake within that 60 to 70 window. Now for this one, if we look at this, half the class did better than a 75 and half the class did lower. So again, doing worse than the 75, you could have gotten a 74 and we could have had a bunch of kids who got 74s. So we really can't conclude the retake situation for these two classes, but we can definitely conclude the retake being right at the 70 and saying half the class and half the class for these two. All right, switching gears, we're back down here to letter choice C. 50%, so half the fourth period, scored between 85 and 95. So let's go take a look at the fourth period box plot up here. So for fourth period, we care about 85 to 95 on the number line. So 85 is right here. And then 95 would be right here. So for fourth period, that actually isn't anything on my box plot right there. And if anything, 25% falls in this category from here to here. So there's no way 50% is in there. So this is definitely not a true statement. If it had a range here that had two of my quartiles, for example, if it said something like got from a 50 to the 80, I think I said an 83. If it said 50% of the students got somewhere between a 50 and an 83, if it had switched that up, then it'd be true. But that's not what it said, so we're not going to pick that one, okay? All right, the scores in third period are more spread out than the scores in fifth period. So looking at third period, looking at kind of the length of the box and whisker plot versus this one, it looks like to me, since fifth period is more elongated, this is the data that's more spread out. So we're not going to select this one either because fifth period is actually more spread out than third. All right, only 8 students passed the test in second period. So this is a good question. So if we're looking at second period right here, where there's 22 students. Now it says only 8 of them passed the test. Now, we already talked about passing and failing kind of being above or below the 70. So if I'm looking here and I'm looking at the number of students who passed the test, it's all of these kids right here. Now that's half the data. And half the data, half of 22 students should be 11 students. So there's actually 11 students that fall in this category. And this says that only 8 fall in that category. So we are not going to select this one. Now for answer choice F, it says 6 students scored below a 45 in fifth period. So let's go focus on fifth period up here. And it's asking if 6 students scored below a 45. Now here's the 45, and I'm going to follow that up. So I'm right here. If I care about the number of students who scored below that line, that's a fourth of the data, 25% of the data. Now I do know that the class has 24 kids in it, so I can do a fourth of 24. A fourth of 24 is in fact 6. If we do 24 divided by 4, we do get 6. So yes, there are 6 students in this chunk. There are 6 students in this, 6 students in this, and 6 students in this. So yes, this one is a true statement. All right, and for the last one here, we focus on fourth period, so the one right below it. And it says 7 students scored below a 50 in that class. So here is the 50. And again, that's a fourth of the data. And if I look at a fourth of the data, a fourth of 28 students, 28 divided by 4 is in fact 7. So yes, these are true statements. So as I kind of walked you through answering those questions, I kind of showed you all a variety of scenarios. I could have said for this class, for example, for first period, I could say, hey, how many students scored at or above this right here, which to me, that looks kind of like an 87. I could be like, all right, how many students scored an 87 or higher? And you'd be like, all right, well, it has to be half the class, so it must be 15 kids who scored in here. I could ask how many students scored somewhere in here, and you'd say, okay, about a fourth of the class. And in that case, when we do 30 divided by 4, we're going to get a decimal. And so it's going to be either 7 or 8 students. 7 or 8 students are represented in that chunk right there. So we can answer questions about how many students fall in each category. That came up in the previous class on that box and whisker plot when it was asking how many kids scored in each of the chunks. It was 6 for each of those. And 6 in each of them represented a fourth of the 24 total. So again, going back to the idea of a fourth of the data or 25% being in each quartile. All right. Now for the last question here on this page, between second and third period, if we're looking at just in second and third period, which class do you think did better? All right, so between second and third period, the reason I'm asking about those was because you might have noticed that they had the same median. And for both classes, I can say half the class passed and half the class failed. But for me, the reason I think I'm going to say this class did a little bit better is because right there, half the class did a little bit better than this half of the class. And that's really not the best, most solid reason in the world. We can also see here that the fourth of the class here, look at the top fourth of this class compared to the top fourth of this class. The top fourth of this class got 85s or higher, while the top fourth of this class only got 80s or higher. So again, now I'm kind of giving two reasons why me personally, I'm going to go with third period. And again, that's just because this interquartile range, this box is a little higher up on the number line, and this top fourth of the data is a little bit higher up than this top fourth of the data. And that's kind of what I would summarize right here. Once you summarize that for third period, let's flip over. And we've been talking a lot about test scores, which just because that's a type of data that a lot of students your age can relate to. At your age, a lot of people care about grades. Another thing that I really care a lot about is like our heart rates and maintaining a healthy lifestyle. So what I've got here on the next page is a chart, and I want to give you guys just a brief vocab that RHR, that simply stands for the resting heart rate. Now, athletes, when I talk about athletes, I'm not talking about like a mom or a dad who works out a lot. I would say that if you have a parent who actually competes in half marathons or marathons pretty regularly, that you could consider them an athlete. I think a lot of us have family members who compete on a traveling team. Like some of us have family members, like a parent who competes on an adult tennis team. So yes, if they're actually competitive, you can consider them an athlete, but just going to the gym, I wouldn't consider going to the gym regularly or just running regularly on your own an athlete in this case. And I just kind of wanted to clarify. But RHR is a resting heart rate, and we can see here that athletes generally kind of fall into the category that has the lowest resting heart rate. Then we have awesome. Your health is like awesome. Your health is excellent. Very healthy, healthy, below average are poor. Now I want to explain in the chart real quick first before we do anything down here that you guys don't even fall into this category yet. You guys are still younger than this category. But let's talk about like once you guys kind of are at the point where you're graduating high school and thinking about college or starting to be on your own a little bit, when you're looking at your heart rate, having something that's in the 60s is going to be kind of the range that you want to aim for. And you can see that as your heart rate increases, as your heart rate is increasing, that means your health overall is decreasing. And it's because your heart is having to work extra hard to pump the blood. And that could be for a variety of reasons. But generally, we don't want your heart working really hard when it's just sitting and kind of resting. So that's why we look at your resting heart rate and kind of determine how your overall health is. And again, the more in shape you are and kind of follow like a better diet, the lower your resting heart rate is, meaning your heart's not working very hard to pump blood when it's just relaxing and chilling. But if you are not in very good health, I mean, your heart is like pounding even when you're just sitting on the couch, and you'll hear people like out of breath, even if they walked up just like 5 steps, and their heart is working really, really, really hard versus like 5 steps for an athlete is not a big deal at all. So that's just what's going on here in the chart. And that's just kind of like as your age gets older, these ranges do kind of change a little bit. But for you guys, as you're teenagers, you certainly want to be, you can kind of see somewhere in here in that 60s-ish range is a pretty good call. And if you're in the 70s, you're healthy and kind of starting to get a little bit below average. But again, you guys aren't even in the chart quite yet because your bodies are still growing. Oh. All right, now let me just erase this and kind of talk a little bit about this first question. So according to the chart, if you are 29, so being 29 puts us in this age range, okay? If you have a heart rate of 68, does that mean you're in good health? So if you're in this age range and your heart rate is 68, it's right in here. So that means you are very healthy. So, yup, you sure are. We're going to put yes here because 66 to 70 on the chart is very healthy. So you are in good health. Okay. So just kind of getting comfortable with reading this chart. All right. According to the chart, what would be an unhealthy heart rate for an 18-year-old teenager? Okay. It says your answers may vary. So for an 18-year-old, we're looking back in this top row. and we're trying to find an unhealthy heart rate. So this is good, 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 good. And then right here, you are now below average the moment that your heart rate is 74 or higher. So the way I'm going to answer this question is basically if your heart rate is 74 or higher, and that's how I'm going to indicate it, 74 plus. If your heart rate, your RHR, your resting heart rate is 74 or higher as an 18-year-old, that's not good, y'all. That is not good health. So I'm hoping that this video kind of sticks with you. And I know a lot of us wear smart watches. Not all of us have like an Apple Watch or something like that, but a lot of us do have ways to track our heart rate. And I just I even challenge you right now, if you have one on, look at your resting heart rate. I mean, you've been sitting here watching this video for 20 minutes now. I mean, you're probably falling asleep at this point. So I don't think you could get any more relaxed than you are right now. And when you look at your resting heart rate, I mean, if your heart is racing right now and you're in like the 80s or 90s, I mean, that's just not a good sign. Now, depending too on what you've had to eat today, that has something to do with it. A lot of times caffeine will increase your heart rate and things like that. But anyways, it looks like 74 or higher puts you in bad health. Okay. Now what we have here is a box and whisker plot showing that same data. Your resting heart rate and your pulse are basically the same thing. So in this case, what we have is we're focusing on people who are ages 36 to 45. So I'm going to come up here. The box plot does not represent the entire chart up here. It represents people who are 36 to 45. Okay. So this is what I care about for the box and whisker plot. It also says here that we have a group of 200 people represented in the plot. So the first thing that I want to point out to you is that in each of these 4 sections, we're going to have 200 divided by 4 people, which is 50 people. So there's 50 people who have a heart rate from here to here. There's 50 people who have a heart rate from here to here. There's 50 represented in this chunk and another 50 people here, because 50, 100, 150, 200 would be everybody in the data set. Okay. All right. The first question we have here is how many people in this age category have a healthy heart rate? Now in this category up top, healthy was right here. Healthy is having a heart rate between 71 and 75. So when I come to my box plot, I care about this right here, the 71 to the 75. And it's a little bit off the way I just drew my lines, but I think if you look in your packet, you'll see that that's the 71 to 75. So this is 25% of the data. Okay. And we already just said that 25% of 200 people is 50 people. So 50 people in this data set have a healthy heart rate. All right, how many people have a below average or poor heart rate? So up here, below average or poor basically puts you at anything that's 76 or higher. If your heart rate is 76 beats per minute or higher, then you are in bad health. So I'm going to find right there, that's the 76 right here. So anybody who is higher than that on my box plot is in bad health. In the box plot, I can see that this is the median. So I've got this chunk of data, the 25%, and this chunk of data. So there's 50% of my data is in here. So half the people. Half of 200 people is 100 people. Okay. All right, for the next question, what percent of people have a heart rate that's considered very healthy or better? So let me just erase this stuff. So very healthy or better is now the 67 to 70 chunk. Very healthy or better would mean this or anything really in here, because that's better in terms of your heart health. So this range right here, the very healthy or better, is all of this stuff. So pretty much anything less than 70. 70 or less is a very healthy or better, 70 or less. Now right here, that's where that is on the box plot. So if I'm going for that or healthier, it's this little chunk right here, which is a fourth of the data. and a fourth of the data, a fourth of my 200 people. Again, there's just some survey out there. We're looking at people's different heart rates, and it looks like 25% of them fell into this category right here of very healthy, so only 50 people. Okay. According to the chart and the box plot, how many people have an awesome heart rate? So awesome is right here, which basically means your heart rate is 62 or lower. Okay, awesome. And if I look at the box plot, do you see how nobody has a heart rate that is lower than that number? 62 would be down here. So nobody, 0 people have a heart rate that is awesome. Now, if we want to know what percent of the participants have a heart rate over 70, that's this red line right here. So what percent falls above it? That's going to be 75%. And which is closest to the range? If we take the highest heart rate and subtract the lowest, now we've got a 40, a 30, a 20, and a 15. So let's just kind of estimate here. This to me is pretty close to 110. It's not quite 110, but close enough. And this right here is kind of close to 70. That's close enough for me to realize the spread of the data is about the 40. Okay. Even though it's obviously not the 110 and the 70, again, it's closest. It's easy to kind of see that the range is a 40. All right, couple more questions here, and we're almost done. So true or false? More people have a heart rate above 88 than people who have a heart rate below 70. So when I look at this box plot, let me just erase this. Again, it just asked us true or false. Do more people have a heart rate above the 88? So 88 is this one right here. It's saying, do more people fall on that whisker than fall on the whisker for below the 70? A lot of you are going to say true because you're like, oh yeah, that's a longer whisker, so that's going to have more people than this one. Nope, remember, that's not true. This has 25%, and so does the other whisker. They actually represent the same number of people. There's 50 people who are in this whisker. There's 50 people who are in this whisker. And it just means that the data is more spread out here. When you have bad health, there's obviously like a lot of reasons why you could have bad health, and your heart rate could keep getting higher and higher and higher for different reasons. So being in bad health, you can have a lot of variety in the reason why. When you're in really, really, really great health, there's obviously not a whole lot of room and variety for the greatness. It's like, no, I mean, you have a heart rate that's lower than what it should be, so you're in good health. So when we look at this one, this is a false statement. Just because this whisker is longer, it doesn't mean that there's more people there. No, it just means that the data is more spread out. And over here, the data is just very, very, very consistently around the same number. And for number 8 here, according to the box plot, the majority of participants are in excellent health. Now, when we come back up here and we look at excellent, excellent is somewhere between 63 and 66. Excellent would be somewhere between 63 and 66. Somewhere between 63 and 66 would be right here. Is the majority of our data there? No, not at all. In fact, none of our data is there. So this is definitely a false statement. All right. So there's a lot going on here with box and whisker plots. I think when you guys might have seen the video on how to make them, it's like, okay, cool. I just need 5 things. I care about like what's the lower extreme, the lower quartile, the median, the upper quartile, and the upper extreme. And it might not mean a whole lot when you make just one box and whisker plot, but when you start to compare box and whisker plots, or when you start to actually use them to represent data like up here, it gives you a lot of information to work with, and it really is a good way to analyze, once again, I can't say this enough, consistency. Is the data really, really consistent, or is the data really, really spread out? All right, that concludes today's video. Thank you for watching.